This is section 10.1. We're going to look at properties of tangents. Let's make sure we know what a circle is first. There's a diagram of a circle at the bottom. A circle is a set of all points in a plane that are equidistant from a given point called the center. So notice how we have a dot in the middle of the circle. That's called the center. The circle with center P is called circle P. So for example, let's say that this is point P. You would call this circle circle P, and you would write it like this. You'd make a little circle with a dot in it and put a P beside it. So you read that as circle P. A segment whose endpoints are on the center and any point on the circle is a radius. So this red segment right here is a radius. It touches the center and it touches any point on the circle. A chord is a segment whose endpoints are on the circle. A diameter is a chord that contains the center of the circle. So let's talk about that real quick. A chord in general looks like this. It touches a circle in two different points, and it's a segment that connects those 2 points. Now, the diameter is also a chord. But more importantly, that diameter contains the center. And that diameter is 2 times as big as the radius. The radius is half the size of the diameter. Here's a couple more definitions. A secant is a line that intersects a circle in 2 points. So it looks like this green guy right here. So this line goes through the circle and touches it twice. That's what a secant is. A tangent is the blue line. It's a line in the plane of a circle that intersects a circle at exactly 1 point. And that point is called the point of tangency. So notice how we have this blue line down here that's going to touch the circle in 1 point, and that's that red dot there. That's called the point of tangency. We're going to use those terms a lot. The tangent ray, we'll call it ray AB. That's the ray that starts at A and goes towards B forever. And the tangent segment, segment AB starting at A, ending at B, right there. They're also called tangents. So a tangent isn't necessarily only a line. It could be a ray or a segment. Let's do some examples. Identify special segments and lines. Tell whether the line, ray, or segment is best described as a radius, a chord, a diameter, a secant, or a tangent of circle C. Segment AC. We're going to start at point A, end at point C. Notice how point C is the center. I know that because the name of the circle is circle C. This is what a radius is. Segment AB starts at A and goes towards B. Notice how A and B are both on the circle. That's a diameter. Ray DE starts at point D, goes towards point E forever. That's a tangent. And we'll be specific since it's a ray. We'll say it's a tangent ray. Segment AE. I'll use green. Oh, I'm sorry. I might have said segment. That's line AE. That's what you call a secant. Segment AG. I'll use this red. Starting at A, stopping at G. A and G are both on the circle. That's a chord. Name a tangent and a tangent segment. Well, remember that purple there is a tangent ray. If you want a tangent line, we could write it as line DE. If you want a tangent segment, You could do a couple different options here. You could throw B in there if you want, or you could just say segment DE. But obviously any segment that's part of that segment would be a tangent as well. Oopsies. Let's talk about a radius and a diameter. The words radius and diameter are used for lengths as well as segments. For a given circle, think of a radius and a diameter as the segments, and the radius and the diameter as the lengths. So if I ask you for a radius, I'm asking you to name a segment. If I'm asking you for the radius, I'm asking you for the actual length, the number. Okay, so let's use this diagram to find the given lengths. We want the radius of circle A. Okay. Oh boy. Oh, there we go. Radius of circle A, that would live right here. And all you could do is count here. I'm assuming each one of these little units is actually 1 unit. So it looks like the radius of circle A is 3. Now that's the radius. A radius could be there, it could be there, it could be there, it could be there, any of those red segments. What is the diameter of circle B? Well, again, you can draw a lot of different diameters, but the diameter would have a length of 4. A diameter would be that blue segment, or this blue segment, or this blue segment, so on and so forth. What is the radius of circle C? It would be 3. Diameter of circle D would look like that. It would have a length of 4. What's the radius of circle E? It would be this guy. Looks like 4.